an ideal gas is compressed to half its initial volume by means of several processes. Which of the process results in the maximum work done on the gas? Suppose if you plot a graph between pressure on y-axis and volume on x-axis, let us take the initial volume as V and the final volume, which is compressed to half its initial, so we can write this as V by 2. If you take the process as adiabatic, the equation which is followed is PV power gamma is equal to constant. In isothermal, PV is equal to constant. In isobaric, pressure itself is constant. In isochoric, volume itself is constant. So there is no option of selecting isochoric. Let us see isothermal, adiabatic or isobaric. Suppose if you are taking pressure and volume initially, pressure here and volume you can take here. If you compress it, the pressure will be increased according to the relation PV power gamma is equal to constant. So this is final volume, this is initial volume. So the graph will be like this. So this is adiabatic graph. If you look into isothermal, a little bit steeper graph. This is isothermal. This is adiabatic. And isobaric, pressure is constant. So the graph will be like this. Volume is decreased from V to V by 2. The pressure remains constant. Among these three graphs, the area under isobaric graph is very less. So the work done will be minimum under isobaric and maximum under adiabatic. So the answer is adiabatic for this question. Compression of a gas in isothermal process and adiabatic process. Let us draw the graph. Pressure on y-axis and volume on x-axis. Compression. Compression means starting volume will be more and final volume will be less. Let us start the initial volume as V and final volume as V by 2. And initial pressure, let me take it somewhere else on y-axis at initial pressure as P1. And looking the initial state, this is P1 and this is V1. So we were here. This is initial state. You can take this initial state for both adiabatic and isothermal process. Now we will see the final pressure. In case of isothermal process, P1, V1 is V, P2, V2 is V by 2. So V gets cancelled, P2 will be 2P1. If you take the same thing in adiabatic process, initial pressure is P1, initial volume is V, but in adiabatic process we can write PV power gamma is equal to constant. So P1 V power gamma is equal to P2. V2 is V by 2 power gamma. So from here, the final pressure is equal to V power gamma gets cancelled. Here 2 power gamma is there. You can bring this side. So final pressure in adiabatic process will be 2 power gamma into P1. If you compare the final pressures in isothermal and adiabatic, definitely this pressure in adiabatic will be more. So suppose if you take this as 2 P1, this P2, 2 power gamma P1 will be some more high. So this is initial and this will be final pressure in case of isothermal. So the curve will be, this is the final volume. So this is final volume. So this is isothermal curve. And adiabatic, 2 power gamma P1, you can take it a little bit higher. So this is final volume and this is final pressure in case of adiabatic. This is starting position. So this is adiabatic curve. So adiabatic is this one and this is isothermal. Look here. Take pressure on y-axis and volume on x-axis. So let us see expansion of gas. Expansion means the volume might be increased. Take initial volume as V, final volume as 2V. And for initial volume, you can take initial pressure as P at one point. See, this is initial pressure and this is initial volume. So from here we are starting the curve for both adiabatic and isothermal. Let us see in case of isothermal expansion, P1 V1 is equal to P2 V2. The pressure P1, this is P1. Let us see where will be the P2 here in case of isothermal process. And similarly we will see in adiabatic process. V1 is V, P1 we will write P1, P2, and in the place of V2 you can write 2V. So P2 will be, so VV gets cancelled, P2 will be P1 by 2. In adiabatic process, P1, V1 is V power gamma is equal to P2, V2 is 2V power gamma. From here, P2 is equal to V power gamma and V power gamma gets cancelled. P1 by 2 power gamma. Final pressure in case of isothermal process is P1 by 2. Final pressure in case of adiabatic process is P1 by 2 power gamma. If you look into these two pressures, definitely this pressure P2 will be less than this P2. So if you take P2 as in isothermal process as here, which is P1 by 2, this P1 by 2 power gamma will be some more less. So this is final volume. If you look into this, so this is P1 by 2. If you plot the graph from initial state to final state, this will be the graph. This will be the graph, which is isothermal graph. If you plot the graph for adiabatic, so this is P1 by 2 power gamma, some more lesser than P1 by 2. Then this is starting position, and from here, this is the starting position. From here, the graph will be like this. So this is isothermal, this is adiabatic. So adiabatic is some more steeper when compared to isothermal process.